Hi everyone, this is Johnson and Gabe here, and today we will introduce you to the acid rain. There are two types of acid rain, sulfur-based and nitrogen-based. In China, the most populated country, is suffering from sulfur-based acid rain. Why is it happening? What damage has it caused? What can we do about it? Let's check it out.
It all starts with the type of coal one uses. There are mainly two types of coal, soft coal and hard coal. Soft coal contains more sulfur but is less expensive. Hard coal is rare and contains less sulfur. In a growing economy such as China's, the cheaper option is often the better one. And since soft coal is cheaper, more plentiful, although it contains more sulfur, it is the coal of choice for China.
Since 1970s, China has suffered the problem of acid rain due to the emission of sulfur dioxide. But with faster development of industrialization, consumption of coal keeps rising at a higher and higher rate. Luckily, in 2014, the consumption goes down and has been dropping ever since. Yet, in 2015, we still consume 3.96 billion tons of coal, which is 47% of all the coal burned across the globe, which is a serious problem.
When coal is burned, the sulfur dioxide is released into the atmosphere. The sun's UV radiation helps the sulfur dioxide gain an oxygen molecule. This combines with water to create H2SO4, more commonly known as acid rain. Wind currents play an important role in the distribution of acid rain. During the summertime, the winds blow north. However, during the wintertime, the winds blow south. Because it's the winter, more coal is burned as a heat source. This means more sulfur into the air.
Chongqing, a city in China with an annual rainfall around 900 millimeters to 1200 millimeters and the most sulfur in coal, was seriously devastated in the acid rain. The acid rain average pH there is 4.28, the lowest pH is 3, and the acid fog occurrence there is 94%, which means 94% of the fog there is acid fog.
There are a multitude of negative effects that worsen the lives of farmers in China and cause substantial amount of damage to the local ecosystems. Crops that are planted are healthy when it rains with an acid level of 5.6, but with acid rain, it could be a pH of 3.0 or lower. So, when it rains, the crops cannot handle the change in acidity and will wither and die. This is because in the soil there are tiny clay particles. When it rains, the acid reacts with the clay to release aluminum, and lots of it. Aluminum is very toxic to plants and to animals. The effects on trees are just as bad. The aluminum in the soil is absorbed by the trees, making them sick. Furthermore, acid rain also prevents them from taking up nutrients. Acid fog also damages trees and crops. With a pH of about 3.0 or lower, let's take a look. The leaves on trees have what's called a cuticle, or protective covering, that acts as a shield against the elements. The acid fog strips that covering, and without the protective coating, the leaves die, and soon after, so does the tree. This is what happens when acid rain comes in contact with a limestone statue. Now let's take a look at the effects on aquatic life. In a lake or a pond where the acidity of the water is a pH of 5.0 or lower, fish eggs will not hatch. This endangers fish population and prevents farmers in China from having products to sell at the local market. Biomagnification. What is it? Biomagnification is the exponential accumulation of harmful compounds in an organism. As harmful compounds make their way up the food chain, the organism becomes sick and can die.
Now we know its negative effects. What are the solutions? In treating acidified land and water, liming is the most effective way. By adding limestone into the soil, it can neutralize the soil. Also, with limestone inside the soil, it can neutralize future acid rain to maintain the pH of the soil. Sounds effective, right? But we must solve the problem from the root. When coal is burned in the combustion chamber, usually the sulfur dioxide was directly released from the chimney. But we can add limestone into the combustion chamber and then let it react with the sulfur dioxide in the combustion chamber and transform it into calcium sulfite. In that way, no sulfur dioxide will be released. In this method, we have a high efficiency of 60 to 85%, which means 60 to 85% of the sulfur will be gone. But that's not enough. The limestone plaster and the wind also enters the lower chamber. Some of the sulfur dioxide directly reacts, other gases cools down and rises, where it reacts with water and plaster again in the upper chamber. After the clean gas is out, there's only gypsum and plaster in the chamber. They enter a centrifuge, then the plaster is returned back and the gypsum goes out. Gypsum has many beneficial uses and the desulfurization efficiency reaches 95%. This technology is so cost-effective and advanced.